Okay, so today we're going to take a look at part 2. Specifically, the topic in today is scale diagrams and what that means. Okay, so here's what the Manitoba Curriculum says on this topic. This is the specific thing you can be tested on your final exam. Okay? Draw and interpret scale diagrams of 2D shapes. Now after that is a bunch of points about that. I'm not going to read all those to you, but basically again focus on what it says you need to know how to do. You need to take two-dimensional shapes and create and understand what a scale diagram is. So let's start with a little background on this. Okay? So when you look through binoculars, when you look through a microscope or a telescope, you're taking an object and it's appearing to look larger or enlarged, okay? In each case, whether you're using binoculars like this one and you adjust a little switch here, sometimes that's also on cameras, or you take a microscope and you adjust the different lenses here, you'll see different values here that are essentially called the scale factor, okay? What that means is it's scaling the object in a way. As well, you're going to create drawings often of scale things, like blueprints or maps are scale drawings, okay? This is because you can't actually draw the image you're representing in real life. Like, for example, can you get a life-size map of the world? Well, of course not. You'd never be able to fold it, right? Okay, so what scale drawings are they're based on a ratio, okay? So when you see something like this, 1:10, you're not thinking of it in terms of time. It's not 1:10 in the afternoon. This is a ratio of 1 to 10. This is also often expressed in a fraction, 1/10. It means the same thing. But what that means is, for example, if we were building a doghouse, and I drew a doghouse on a piece of paper, and I put this as the scale, it would say that 1 centimeter in my drawing equals 10 centimeters for the real doghouse. So that's the scale factor, okay? It is a constant factor for which all the dimensions, and again, it has to be all of them. So you have to make sure that the height is 1/10 and the width is 1/10. You can't change the scale factor for different parts of your drawing. You can't say, well, I'm going to scale the height by 1/10, but I'm going to scale the width by 1/7, because then the drawing won't be accurate to what it is in real life. So that's what it means by constant. Every single number is affected by the scale factor. It's either going to be enlarged or reduced, okay? If your scale factor is greater than 1, you're going to get an enlargement. If it's less than 1, you're going to get a reduction, okay? I'll demonstrate what I mean by that. Okay, here's a drawing of a car. And I'm going to tell you that the scale drawing of this car is 1:32, or a ratio of 1:32. What it means is 1 centimeter on the drawing equals 32 centimeters in real life. So that's the scale factor. We can put that as a fraction, 1/32, and we can even divide that if we want. We can actually say 1 divided by 32 and get it as a decimal number. All three of these mean the same thing. A ratio of 1:32, 1/32 is a fraction, and this decimal number all are the scale factor. They're numbers you can use when generating that image, okay? Now this is a number, if we think about this number, it's less than 1. We can think of it as a fraction less than 1 or as a decimal number. No matter what, it's a number smaller than 1, which means that we have drawn a reduced version of the car. Okay, let's go the other way. Now, in this one, I have a scale of 5:1, okay? Which means that 5 centimeters on the diagram would represent, would represent 1 centimeter of the actual object. So I'm saying this 5 centimeter triangle is actually much smaller, okay? So when I divide 5 by 1, I get the number 5. In other words, this triangle is 5 times bigger, which means I'm getting an enlargement of that triangle, right? That triangle is being enlarged by that scale factor, okay? It's a pretty simple thing to think about, this idea of scale factor. But you're going to use it in conjunction with problems. So let's take a look at a couple problems. Okay? Let's see if you guys can answer the first one. What does the scale of 5 to 2 mean? What does that mean?
2.5 to 1.
Well, okay, but what does that mean? Okay, like tell me what it means in terms of the context that we're talking here. We'll just use the word units. It's 5 units to 2 units. So that means 5 units on your drawing is equal to 2 units in real life. Okay? Is that drawing an enlargement or a reduction? Okay, are you sure? Yes, it's an enlargement, right? What does a scale factor greater than 1 indicate? It's larger, yeah, right? Now, here's a map. 1 centimeter equals 200 kilometers, or as a ratio. Calgary is 1,400 kilometers from Winnipeg, okay, on the map. How would we determine the actual number of centimeters that would be on the map?
You divide the 1,400 by 200.
You sure?
2.
You divide 1,400 by 2.
100.
Okay.
Something divided by something.
Okay, here's a way you can solve those types of problems, okay? We have a ratio of our map to the world, right? Like in the real world, there's a distance between Winnipeg and Calgary. On our map, there's a distance as well. Think of that as a fraction or as a ratio, the map to the world. On the map, we can have 1 centimeter. But in the real world, what does that equal? Okay, so we check our scale. And you're right, 1 centimeter equals 200 kilometers. So 1 centimeter on the map equals 200 kilometers in the real world, right? This is equal. Now, over here, we have an unknown. We have no, I say it's 1 to, yeah, that's a 1, okay? So now I say here that we know the number of kilometers. The number of kilometers is 1,400. What I'm looking for is right here, the number of centimeters, okay? But all these 3 things are equal, right? What the map in the world equals this equals this. So think about what we have here. We have a fraction of 1 over 200 that's equal to some unknown over 1,400. We have to solve for the unknown at this point. This is kind of a look ahead at our next unit in polynomials. So I think you might have the answer, but let me show you how to do this, okay? There's a couple different ways you could do this, okay? One way is you could turn this into a decimal on your calculator right now if you wanted to, okay? You could do that. You could then take that decimal number and multiply it by this to get you that. But another way you can do this is a technique called cross-multiplying, okay? With cross-multiplying, you multiply this times this and this times this. And what you get is 1 times 1,400 is 1,400. And 200 times x is 200x. Okay, but we're not done yet. So I'm saying 200 times something equals 1,400. To get the something, I divide this side by 200, essentially canceling it, leaving just x. And what I do to one side, I do to the other. What's 1,400 divided by 200? 7? About 7?
No, yes.
Does anyone agree with the 7?
Yes.
It's 7, yeah. So that gives us the answer, 7 centimeters. Okay? Now for some people, they can kind of intuitively, they don't need all these steps. But that's a technique for doing that. Okay? Let's see if it works on the next part. On the same map, the distance from Winnipeg to Toronto is 22 centimeters. What's the actual number of kilometers? Well, we can do the same thing. Well, no, because what we have is we have 1 over 200 equals 22 centimeters to an unknown. That's the distance to Toronto. So what do? We cross multiply. 1 times x is x. 200 times 22. This one was easy. We're done. We have the answer. Okay? So the idea of cross multiplying actually is something that I would recommend you practice in problems like this. It's just a little bit faster. Now again, we didn't have to do it that way. Okay? There were other ways we could have applied it. Yeah. Well, it depends on the problem. For the most part, I think you can just do it in your head. Okay. So you capture an ant, and you want to enlarge it on a drawing. The ant measures 3 millimeters by 2 millimeters. Now, I'm not going to draw the ant, but what would be an appropriate scale? Think about how small that is, 3 millimeters. If you were going to draw an ant, how big would you make it? About, say, that big on your paper? So what would your scale be, approximately? 1 millimeter would equal
3 centimeters.
3 centimeters? That would work. Still be a pretty small ant, though, you'd draw. I think 3 is maybe a bit, because it's only 3 millimeters long. So that means you're going to draw 3 centimeter. I'd almost draw about 20 centimeters, right? Like that might be enough to draw an ant in the picture there. But that's the kind of question. By the way, these questions that I put up here were actual exam questions, okay? A cell phone is 12 centimeters long. But you would see a picture on the side of a building of a cell phone. And in the picture, the cell phone is 32 centimeters. You take out your ruler and you measure the picture. What's the scale factor? Well, the drawing is 32. The actual phone is 12. So it's a ratio of 32 to 12. Could I reduce that as a fraction?
Yes.
To what?
6 over 16, and then you can reduce that again into 3 over 8.
3 over 8 or 8 over 3?
8 over 3.
8 over 3, right. 8 over 3, okay? Last question. Draw a triangle similar to this using a scale factor of 0.25. Will the triangle I draw, if I was going to draw it, be bigger or smaller? If I completed question 5, would it be a bigger triangle or a smaller triangle? How many people think it would be bigger? How many people think it would be smaller? How many people don't give a crap? Well, what's 0.25 as a fraction?
2500 or reduced to a quarter.
A quarter. So if you're drawing it a quarter size, it's going to be smaller, okay? It's going to be a smaller triangle. Now, when you draw it then, you can figure out what each of these sides would be as well. What's a quarter of 8? What's a quarter of 6? What's a quarter of 7.2? How would you do that? How would you figure out what a quarter of 7.2 is? Give me a technique for that.
Divide by 4, possibly?
Divide by 4. Yeah. What about the decimal number? Could you actually use that number? How would you use it? No, you just multiply it. Multiply that number times 8. Multiply that number by 6. Multiply that number by 7.2. On your calculator, that's very easy to do using a calculation. So I think you guys need to practice these types of questions to really get sort of the feel of what they are doing there. Okay, here's your key concepts. Scale factor, talked about it, okay? Your key vocabulary. Know what these 4 words mean in this context, because that's what the Manitoba Curriculum wants you to do. I mean, if you just take any of the subpoints here, like draw and interpret scale, like this one, determine the scale factor for a diagram drawn to scale, right? Solve a problem that involves a scale diagram. This is the kind of stuff that you guys would be expected to do. Okay? So that is it for part 2. It was